In this tutorial, we're going to look at how we define the building systems in the Zebra model. Building systems includes things like the hot water system, the cooling and heating system, and the ventilation system. All of these things have an energy demand. It also includes potentially solar panels on the roof, which generates energy and helps to offset for those other systems. As well as defining the energy demands of these systems, we also need to define the fuels that they use, because this will allow the spreadsheet to calculate the carbon footprints of these systems. This is what the building systems sheet looks like. On the left side of the sheet, we define for each of the building systems the energy demand of these systems, or in the case of the PV panels, the energy generation. And then on the right side, we define the fuels that these systems use. So this will be used to determine the carbon usage of the building. So we start with the ventilation system. We've already defined the ventilation fan efficiency in the space conditioning tab. So these values are really brought forward from that tab and summarized here. Likewise, for the space heating and cooling system, we've already defined a lot of information about the energy demand of those systems. So the values are just brought forward. For the hot water system, we haven't previously addressed this in the spreadsheet. For this, we just define the amount of liters of hot water we're expecting to use, and you'll see some sensible default values here. We just type into this box 50 liters, and then we choose from this drop-down the description that most closely describes the hot water heating system that we have. Based on that, the spreadsheet will calculate an energy demand for that system. For the PV panels, we can define a roof area and the fraction of the roof that we can put PV panels onto. And based on that, the spreadsheet will calculate the amount of solar panels you can place in that area and the amount of energy that will be generated by those solar panels. Now on this side, we have options to set the fuel for the space heating, the space cooling, and the domestic hot water system. We just choose the fuel type from a drop-down here. That's everything we need to do on this sheet for a complexity level of 1. If we increase the complexity level, there's actually a lot of additional inputs to this sheet. So for each type of building system, we have an option to define the auxiliary energy, which is an additional energy demand other than what's already been covered by the spreadsheet. That's true for each building system. For the hot water system, we also have options to define or override the default values for heat losses for distribution and storage, which will make the calculation a bit more accurate if we know values for these. Likewise, for the PV panels, we have options to define their efficiency and performance, which, if we know those values, we can use to improve the calculations. We can define additional systems that are not covered automatically by the spreadsheet here, just to add an additional energy demand. And we can also override the default values for the different types of fuel. So you may want to do this if it's different in your country from these default values that are there initially. On the right side of the sheet, we can now change the fuel type for every part of the systems rather than just these 3. And we also just get much more detailed calculations displayed here, including these charts which summarize the energy consumption, the operational carbon intensity, and the primary energy for each of the main building elements. So that's an overview of the building system sheet in the Zebra model. In the next tutorial, we're going to look into embodied carbon.